audible?
Yes, ma'am.
Okay, thank you. Okay, so in the last class, we have just started with another topic called UNIX file system. Okay, so this is the course outcome of this module, that is demonstrate UNIX file system and use of basic commands. So we have finished one part of this course outcome, that is use of basic commands. I have explained so many basic commands, how it works. Okay, I have executed and I have shown the output also. And in the last class, we have just started in brief about the UNIX file system. So I'll just continue with the UNIX file system. Okay, before going to the next topic, I'll just revise once what we have discussed in the previous class. Okay, like many were absent in that class. And so here knowledge level, you need to remember what is the course outcome and what is the knowledge level of this module. So knowledge level of this module is K3. Okay, what is K3? Anybody knows? It is apply. Okay, so you should able to apply uh, depending on how you want to get the output, whatever the knowledge you have gained. So you need to apply that knowledge to solve the problems. I will give, I think today or tomorrow I will be assigning assignment. So where I have given some problem statement, you need to use the whatever the knowledge you have gained from the basic commands and also Unix file system, and you need to try to solve those assignment questions. Okay. So let's start with the module 1. So today we'll be just focusing on the basic file systems. What is file? Okay, so if you just look into the file system of Unix operating system, everything it is represented in the form of file. Okay, so file is nothing but it is a container where it contains some information related to the device. Okay, and any Unix system has thousands of files. So if you just open and check it, you can see so many files. So later I will show you how the file system is organized in Unix. So what is file here? So file is a container for storing information. So depending on the user or depending on the system, it may contain some relevant or the important information. So as a first approximation, we can treat it simply a sequence of characters. Okay, or you can just consider it as a sequence of characters. Okay, it is not just sequence of character. It may be having some meaning, whatever the information or the data that is stored in the file. Okay, so whenever you create a file, so in that file, neither the file name nor its size is stored in the file. Okay, it is not going to maintain any information regarding about that file in the file itself. Okay, it is not storing the file name or it is not going to store the size. So to store this information, we have a separate storage, like a separate file where it is going to keep track of what are the files that are existing. Okay, what are the files you have created and what is the size of that file, what is the type of file. So everything it will be stored in the other part of the hard disk. Okay, but when you create a file, it will be having the information. So whenever if you want to know what are the file attributes, okay, normally file attributes, what is the name, size. So these are all the complete information, permission, where it is located. So this complete file attribute information, it is kept in a separate memory part. Okay, so that is in the hard disk, it is going to store in a separate file. Okay, whatever the files that are created or stored in the hard disk. So complete details will be stored in a separate memory in the hard disk. So what and all files are existing and their attributes. Okay, and these file information, it is not possible directly to access by the users. Okay, but only the kernel can access. So if you want to know what and all files you have, okay, how it is maintained, it's not possible for the common user. Only kernel is going to open that file and it can view what are the files it is existing, all those things. You can just recall in operating system if you have studied. Okay, where how file information is maintained. Do you remember how files are stored in the hard disk? Is it like just continuous memory location? It depends. It depends on type of file allocation mechanism it is stored. Okay, and also there will be separate link where it is going to keep track of all the file information, and this information it is referred by the only the kernel is going to refer this information, not the user. So now you need to understand what are the different types of files that is existing in the Unix. So here there are mainly ordinary file, directory file and device file. The files can be categorized into these three types. Okay, the first one is ordinary file. So normally we call it as regular file. So it contains only data as a stream of characters. Okay, ordinary file means it contains sequence of characters or stream of characters. Then directory. So example, whatever the program you have created, 1.c or C program. So that is an example of ordinary file. Then directory file. So it is nothing but folder. So many times I already repeatedly told. So we'll not use the term folder. In Unix environment, we are going to use the term directory. Okay, it is nothing but a folder containing the name of other files. Okay, it is a container. So you just uh, you can use mkdir, okay, and you can create a file with specified directory name. Okay, so if I want to create directory with my name, okay, I can create this. I need to change to this directory by using command called cd and give the directory name. Okay, then immediately it is going to change to this directory. Then I can place all the files are relevant to me, or whatever the files I am going to create, everything I can store it into this file. Okay, so these are the commands we have already executed. In detail we'll discuss later that part. So here directory, it is not necessarily it may contains only file, it may even contains the subdirectory. Okay, so that is folder within the folder. So subdirectories, within that it may contains another subdirectory then followed by files. So that is how the files are organized in the directory. Next, device file. Okay, whatever the devices that are connected, normally we call it as a peripheral devices. So for each of the device there is a specified file associated to it. So all such files we call it as device files. Either it may be a mouse or keyboard or any other input output devices. So there is an associated files. So those files we call it as a device files. So these are the main three categories of Unix file system. So we'll just discuss in detail about the ordinary file. So an ordinary file is the most common file type containing stream of data. So this type of file can be further divided into two types. Okay. So ordinary file you can just divide it into two types. One is text file and another one is a binary file. So text file contains only printable characters. Okay, printable characters. Example: all alphabets. Okay, numbers and special symbols. All those things. So all C and Java program source. Okay, examples for text file. So the programs written in C or Java. So these are all called a text file, or it may be a shell script, Perl script. So what is shell script? You are going to learn shortly. Then Perl script, text files. Okay, you may be creating notepad in that if you are entering some text information, that is an example of text files. So these are all comes under text file example. Okay, so what is text file? Where it will be having the printable characters. When you type something, it should be displayed on the screen. So those type of characters or whatever the keys you can find in the on the keyboard, so those are all called printable characters. If text file contains line where each line is terminated with a line feed. Okay, so each line it is terminated with a line feed characters. That is to show the new line character. So as soon as all the normally the length of each row, it can carry or it can hold 80 characters. Once it is exceeds, so automatically it will be taken into the next line. Okay, that is called as line feed character. So this is about the text file. So next we'll move on to binary file. So the name itself, it tells binary file. So normally what type of information the binary file contains? It contains both a printable character and non-printable characters. Okay, and also it covers the entire ASCII range from 0 to 255. Okay, non-printable example. So whatever you are going to use, escape, okay, the tab. So these are all comes under delete button, whatever you're going to press from the keyboard. Okay, it is not going to print any character. So those characters we call it as non-printable characters. Binary file, it contains both a printable and also non-printable characters. So most Unix commands are binary files and the object code. Okay, so binary file means the most of the time it is represented in the form of zeros and ones, where we call it as a object code. Okay, we call it as a object code, or it may be executable file. So that produces by compiling the C program or any other high level language program. Okay, so any program you just compile it, so that will be converted into binary files. So normally it is going to produce the object code. So example for ordinary file, in that binary, so example picture, sound, okay, video files are examples of binary files. Even though if you take an example of image, so whatever the image you can look from the screen, it is not same as that. So internally the image is represented in the form of zeros and ones. So that's why it is an example of binary file. Okay, so next we have second type of file system, that is called directory file. So directory contains no data. Okay, normally directory means folder. Folder, it is not going to contain any information. Instead of, it is going to contain the set of files, or it may contain the set of subdirectories. So in Unix file system, so the files are organized with number of directories and subdirectories. Okay, it is like organized in the form of, I will just show you in Unix environment how files are stored. So there is a root directory followed by bin, then we have etc, then in that subdirectory we have a set of files. Okay, organized where it contains files. Okay, so this is cat command and this is date command. These are all files, and bin is the a subdirectory. Okay, you can just view in the form of tree structure. So directory file contains an entry for every file and subdirectory that it houses. So it will be having the complete details, what and all the files it is having and what are the subdirectories. Okay, and there is an entry means like it is going to keep track of how many files are present in that particular directory. Okay, whatever the text file it is there, or any other binary files, or it may be a subdirectory. So that complete information it is going to be, it is going to keep track of all the file information. So what type of information the directory is going to keep track? Okay, so each entry has two components here. One is normally it holds the file name and also unique identification number for the file, or it may be a directory. See how whenever process is created, so we already know that there is a process ID to identify the process. Similarly, whenever a file is created, it is going to assign the unique identification number. So that identification number we call it as inode number. Okay, so now directory is going to keep track of file name and also the identification number called inode number. Okay, so how this inode number is maintained, how you can just, so you can just recall in the previous class we have executed one command called $ls okay, or minus L. If you give, you are going to get the complete information of the file. So where in that second column was telling about this inode number, okay. So don't worry, we'll discuss in the further topics what is this inode number, how it is maintained. So as of now, you can just remember it is a unique identification number for the file, or it may be a directory. So next is device file. Okay, so every device file has some attributes that are not stored in the file but are stored somewhere else in the disk. See, whatever the file it is created, either it may be a ordinary file or it may be device file. So all the file information, it is stored in the disk, because as soon as if the kernel want to know what is the file, okay, for execution or to open that file and get the data, so it is going to that particular location where it is keeping track of all the file information. Okay, it will come to know that what is the address, okay, what is the name of the file. So all that information, once it is identified, so further if it requires to open that file, all those things that can be done further. So here in this hard disk, it will just maintain the file information. Okay, so that is applicable even for the device file. Okay, the name itself tells device file, whatever the peripheral devices attached to the system. Okay, so for every device there is an associated file. To function or to operate that particular device, it requires to have some set of files. Okay, example, if you want to use wireless mouse, it requires the corresponding file should be available in the disk. So normally we call it as device drivers. Okay, so what is device drivers? So where it is having set of files are related to that particular device, that should be installed on the disk, then only it is going to work. Without device drivers you cannot connect any of the devices. Okay, so like that, for all the device it should have some set of device files that should be maintained somewhere in the disk. So the somewhere in the disk, that means it is taken care by the kernel. Okay, so where it has to be stored, how to access that, all it is the responsibility of the kernel. So here the kernel identifies the device from its attributes. I told here it is going to keep track where file name, okay, what is the inode number, what are the permission it is given, everything, the complete file attribute information, it is going to be stored in the disk. I am not talking about the file, I am just talking about the information related to the file. Once it is maintained, whenever kernel requires to access that, it is going to first check that file information, okay, file details, then only it can access the required file or device file and perform the operation. Then uses whatever the file it requires and it performs or it operates on those devices. So any queries? So if you have any queries, you can ask. So let me just go to the Ubuntu. I'll just show you like how these files are organized. Are you able to view my screen? Yes.
Yes, ma'am.
Okay, thank you. So you can just, once you log in, click on dashboard. Okay. So it's not required to click on dashboard. You just click on home folder. Okay. So where you can see whatever the folders I have, I mean the files I have created, that is stored in the home folder. Okay. So maybe in the previous class I have shown how to create directory, all those things. So all that files you can just see there is a output file, object file, and also C program file, text file. So these are the different files that are existing, and these you can see the color, and this is the folder. Okay, so it may contains folder, I mean the directory, within that it may contains the subdirectory also. Okay, so here there is nothing, no data. You can just see this is a directory ns all in one, and that is containing some subdirectory and also the files. Okay, that is how it is arranged the information. So next I'm just moving to file system. Okay, you can just see all the files related to the device. Okay, there is a bin directory. Okay, in the bin directory you can view all the commands. Okay, whatever we have executed, cat command. Okay, then change ownership, then date command. Can you see all these? These are all executable file. You cannot just modify directly. You can see the icon that is represented for executable file. Whenever you just give any command from the terminal, so the corresponding program get executed. Okay, if I give date, you're getting the date information. Okay, that means there should be somewhere the code for this date command. Okay, that is available in this bin directory. You need to go to file system. In that there is a bin directory. Here you can just see there are so many directories where they have done the segregation of the files. Okay, so we'll just go through that directory structure so that you will understand. We'll go in detail what each of these directory, important directory it contains, etc, lib, all those things. Okay, so whenever if you want to specify the file name, there is a limitation and you need to remember what are the file names you can just specify. Okay, file name consists of up to 255 characters. It should not exceed more than that. Okay, that is one condition. So file may or may not have an extension. Okay, so if you have observed, so many times I have created the files where you can say for this there is no extension. There are some files it requires some extension should be specified. Okay, this is not having any extension, but still you are able to open. This is created in the previous class. Okay, so I think in the class itself I have created this file. So this file is not having any extension. So if you go to some other file, so this is I have created the HTML file. You can see I have given the extension. That means depending on your requirement or what program you want to execute, accordingly you need to specify the extension. Okay, and also file name can comprise of multiple embedded dots. Okay, this is how you can specify the file name. Still it is acceptable. A dot, B dot, C dot and E. So E is perfectly a valid file name. So even you can use the period, that is dot, hyphen, underscore. These are the characters you can use when you are giving the file name. Okay, and also file name can begin with a dot and end with 1. Okay, the all combination you should know like how you can give the file names. But one important point is, so Unix is a case sensitive. Okay, it is sensitive to case. If you have observed in the last class I have given, if I give dot, even the command that is date in capital letter, so it is not going to recognize. You should get an error. Okay, command not found. So all the information or the file names or the commands, everything it is case sensitive in Unix. Okay, so whatever you are going to represent, capital a letter or small letter, combination of zeros and ones, so it is going to be a different file names. Maybe just if you are looking at this side, you can come to know that both the file names are same. No, this is small case and this is capital letter, so both are different file names. And here are some examples of valid file names. So I already told the file name can start with a dot, last and underscore line. Okay, list dot. You can use any of these. In this way you can specify the file names, so it is acceptable in Unix environment. And this is very important, Unix file system tree. So now itself in the previous slide I explained how files are organized. Always the file organizing files, it starts with a root directory. Okay, so this is the root directory. Normally we call it as the admin part. Okay, when we log in using admin, so we start with the root directory. So from this root directory, we have subdirectories. What are the subdirectory you can view? We have bin, dev, etc, home. So home, whatever I have shown here, list of files, can you see? This is the home directory. You can see all the files, whatever I have created. Okay, in case if I've installed any of the software, so that can be installed in this home directory. If you want in the other directory, that can also be done. Then lib, sbin, okay, tmp, user, var. So these are the different subdirectories available under root directory. Okay, if you go one more level tab, so this subdirectory bin directory, it contains set of files like the files related to the basic commands, cat, date, who, okay, whatever the commands we have discussed, so all that commands it is present in bin directory. Okay, you just go to file system, click on bin, and you can view that all the commands related files. Okay, chmod. So today I'll explain about what is the chmod. Then cp, date. Okay, whatever you can see here, echo for printing the text information, whatever you want to print on the screen, normally we'll use echo. Okay, so like that we have, there are so many other basic commands. So we'll discuss those commands one by one. Okay, ln. So there are so many commands, you can just make use of that without using mouse and keyboard. Keyboard is must. Without using mouse, you can just work using the terminal. Okay, once if you are familiar with all the commands. So now what I am doing is I am just trying every time I am just using the mouse. Okay, using the interface, I am just trying to display the things. Okay, so if you know the commands, everything you can just click, type the commands, and you can open the things whatever you want, and you can perform the required operation. Okay, so that is how you should be able to flexible to use those commands without using any of the input device. Okay, so that comes through like based on your how much commands you can remember. Start using the commands, performing all the operations, so that you can remember the command. So just reading, it's not possible. Okay, you have to install the software, try to use those commands frequently so that you can remember. Then in home directory, I have a subdirectory. You can just view these are the subdirectories, and in this, so there is a subdirectory. Within that you have login.sql. Okay, save. There are some other files that are stored in this subdirectory. Okay, and so followed by remaining directories. Let's go in detail with the important directories. So slash bin and slash user bin. So what are these directories it contains? So these are the directories where all commonly used UNIX commands are found. Okay, and that I have already shown in the bin directory, like how it is storing all the files related to the command. So next we have sbin and user bin. Okay, can you see there is a sbin command, I mean directory. So in that also there are some files. What type of files it contains? Sbin and user slash sbin. So if there are commands that are you can't execute, but system administrator can. Are you getting? So in the previous class I told there are some of the commands that you cannot run. So even if you try to install some of the software when you are in user mode, so you may get like a error message like you are not permitted. So in that case you have to change the mode to admin mode, that is root mode, then try to install. Okay, so in case if the files to be executed under root mode or the admin mode, so you need to those commands are stored related to admin in sbin and user slash sbin. Okay, don't get confused here. So this is for all the basic command, and this is the commands that are not executed in the user mode. and to be executed in the administrator mode. So those commands will be stored in this directory. Okay. Then we have etc/etc. So this directory contains configuration files of the system. Okay, it contains the configuration file information of the system. Okay, you may not understand all the things here. So these are the subdirectories related to the configuration of the operating system. Okay. So once if you are thorough with the commands and if you start working in this environment, slowly we will come to know that what are these files, how, who is going to use, all those things. So your login name and password are stored in file, that is etc/password, okay, and etc/shadow. So let's see, those folders are available. Just type here P. Can you see? So the all the files related to password. So who can change the password? We have already discussed. That can be changed only by the administrator mode. Okay, when you are running using root mode, so you can change the password. So such files will be available in this etc, and also shadow. So these are all related to the login and passwords. So related to login and passwords, all the files it is stored in /etc folder or the directory. So next we have /dev. Okay, so this directory contains all device files. Okay, DEV stands for device files. So these files do not occupy space on the disk. Okay, it is not going to occupy any space on the disk about this file. Only the file information it will be stored. So next we have lib. Okay, then user/lib. So that lib stands for library. So this directory contains all library files in the binary form. Okay, so depending on what software you have installed, the corresponding the file information it is stored in the lib. You can just see it is related to sound, okay, firmware, recovery mode, something it is related to the device. Okay, these files are related to the device, and these files are in the form of binary form, that is executable files. Then user/include. Maybe everybody knows that where you will use include. Yes, no, everybody have used include, include, stdio.h, that is in your C program. So these, that means it is a header file. So all the header files that are used for representing or writing C programs, it will be stored in user/include. So this directory contains the standard header files used by C program. The statement like #include stdio.h used in most of the C program refers to stdio.h in this directory. If you want, you just go to user directory and check for the include file. Can you see there is a subdirectory called include. So in this include, normally whatever the files you are going to include to execute the C program that are available here. So there are many files are available. So related to C, C++, for that whatever the header file you are going to specify. So all that header files you can just see in this directory. Okay, you can just see here stdio.h. It is present in include directory subdirectory stdio.h file. And if you want, you can just open and see what and all code it is present in this file. Okay, so what is this seek, set, current? So this you're going to learn from third module onwards. Most of the whatever the functions or the standard keywords you can see. So once you learn this subject, you will be able to understand so many key terms are related to the header files also. Next we have another directory called TMP. So the directory where users are allowed to create a temporary file. So not only in Unix, even in Windows. So all the temporary files, whatever you are creating, it will be stored in TMP directory. Okay, and those files are stored temporarily. So frequently, whatever the files you are going to store in this directory, it is not going to store permanently. So it will be regularly, it is going to remove or clean up this particular folder. Okay, these files are wiped away regularly by the system. System is going to take care of. So how long it has to hold that? Okay, and it is going to erase those files once that time elapses. Then we have slash var, so that is the variable part of the file system. It contains all of your print jobs, okay, and your outgoing and incoming mail information, okay, related to mail. So even you can just try using command, okay, using command how to send the email, okay. So that is also, it is possible using just simple basic commands of Unix. Okay, so somebody else, you can just try that. You can just open two terminals. You can just open two terminals, not necessarily always one. So just type your terminal. Okay, you can just say I have created two terminals. Okay, so in one terminal you can just send the request, in another terminal it should able to respond. Okay, so that is, it is going to act as both client and server. So that can be done using by creating multiple terminals, or you can just do using different system. That means here I am going to send a mail from this terminal, and that should be sent to the other person in the other terminal. If you are doing in the same system, I will be considering this is a different user. Okay, or you just make a LAN connection of two systems and send the mail using the Unix command. That is possible. So I have not discussed about those commands. You can just try by yourself how to send email using Unix command. So next we have slash home, that is the user directory. Okay, on many system users are housed here. That means once you just uh, open your operating system, okay, once it is switched on, whenever if you just click on terminal or click on this, it is going to locate to a particular location where the user can create the folders or the directories files in this particular location, that we call it as slash home. Now currently if you check, I am in home directory. Even in the terminal, if you want to change, you can change the directory. So this is my home directory. And if you try to create here any file, like, let me just show you, and that will go to home directory. I'm just trying to create using concatenation command, that is cat command, with a redirection, and I'm giving the file name file.txt and click on enter. Okay, it is asking for the content. You can just type whatever the content you want. Okay, how many lines, it's left to you what content you want to add. Once it is done, press Ctrl D. Okay, press Ctrl D, it is going to come out of that particular file, and it is going to prompt for the file. So now you can just check that file is created in this directory. Okay, so this is the file I have created. So whatever the file, normally until unless you don't change, by default it is going to place all your directories and files into home directory. Okay, so however system may use different location for home directory. So how you are going to set that will be considered as the home location. You can create your the directory name with your name, okay, and you can specify that as a home directory store all your files. Now how you can represent, are you people are understanding? Can somebody reply? Yes, Shijal, Spurti, Arshita.
Understanding, ma'am.
Okay, so if you have any query in between, you can just stop me. So next, there is one small topic. I'll just go through this, then we'll stop and start your preparation because tomorrow I'm going to give one assignment. So now onwards, the assignments are going to be difficult in the sense you need to think and answer. It is not the same like getting from the video question paper. No, okay, you have to think and you have to answer for those assignment questions. Okay, so parent and child relationship. So based on how files are organized, you can just represent the file system in the form of parent-child relationship. So here the root directory slash as the number of subdirectories. Okay, we have observed that in the previous diagram. So this is the root directory. Under this, you can see so many other subdirectories. Okay, so always when I tell a root directory, it is represented with a forward slash. Whenever if I use forward slash, it indicates that it is a root directory. Okay, so root directory has number of subdirectories under it. These subdirectories have more subdirectories and other files under them. We have discussed now how the files are organized. It is not only the files, the directory may contain even subdirectories and also files. So for instance, home directory under root, and so this is the name of the home directory I have given. You can just specify whatever the name you want for the home directory. So here I'm just specifying Pankaja in my system because this is like the image of the Ubuntu software I installed from the college. That's why the my home directory it is showing it as SVC. Okay, that you can just check it in the terminal. Okay, and also it is having some of the files in this root home directory called login.sql. Okay, so here every hierarchy contains a parent child relationship. So always the root directory whatever you are specifying with the forward slash, that is represented as a parent. We can conveniently say that whatever the directory you are going to create is the parent of another file under in that directory. Okay, so you can just go to that file system. So login.sql. Okay, this is the a child file. Okay, it is the parent of this particular file is whatever you are going to here. I have specified some names. Okay, so this is going to act as a parent directory. So now from this, so the parent for this child it is home directory. So this is how you are going to represent home directory. I mean the parent and child relationship based on how the files are organized. Okay, so now whatever the four subdirectories I have created, for all of those subdirectories the parent is the root directory. Okay, whenever if I specify root directory, remember this forward slash that indicates the parent directory, or it is the parent for the root directory is the parent for home directory. Okay, under home root directory you have the home folder or the directory. In that you have other files are stored. So this is how you can specify the file system as parent child relationship. Okay, now how you are going to represent these parent-child relationship for representing the file name? Normally, you are going to specify forward slash to indicate the root directory, then followed by the home directory, then whatever the subdirectories you have created, name of the subdirectory, then followed by file name. So here, according to this example, it is login.sql in case if this directory is existing. If not, whatever the directory you have created, that directory, home directory, you need to specify. This is root directory, home, then subdirectory. In that there is a file. Okay, no two files in the Unix system can have identical absolute path names. Okay, you cannot create two files with the same name in the same directory. Okay, normally you are faced creating a new file with the same file name that is already existing in the folder. Okay, maybe you have come across with this problem. It will raise an error indicating that there is a file already existing with the same name. Okay, either it will ask for replace or to create new one with a new other name. You can have two files with same name but different directories. Okay, so consider now in home directory I have login.sql. So now in this home directory I may have another subdirectory, okay, within that I can have the same file name. Okay, that is allowed, but it should not be in the same subdirectory. It can have same file name in the other subdirectories. Okay, so now in case if you want to know what is your home directory, what is the path you need to represent, just try to echo your home. So it will specify which is my home directory. Can you see? So my home directory slash home slash svce. Depending on what is the name you're going to give while doing installation of this software, you are going to get that. Okay, so this is the command used for checking what is the what is my home directory. Okay, you can just echo it. Even not only for this, whatever the variable names you want to print, if you want to know what is the shell I am using, echo dollar shell. Okay, it will print what type of shell I am using. So everybody already knows that we have different types of shells. In that I am using bash shell. So this is how you can just check what is the value of this particular variable you are going to use. You just echo it, you will get the value of that particular information. Okay, and some of the directories it is going to represent tilde symbol. Okay, this is we call it as tilde symbol to refer the home directory. Okay, normally we'll use forward slash, but in some of the shells it is going to use this symbol, tilde symbol, to represent the home directory. So for instance you can just instead of this, so you will be getting like this. So dollar home slash the foo, it is a directory name, subdirectory name. So now instead of this you can just use tilde symbol followed by the subdirectory name. That is also acceptable. Okay. Okay, we'll stop here. Thank you. We'll meet in the next class. We'll discuss further about the permission and all, how to set the file permission. You can leave from the session.